The Day Earth Almost Died Part 1. About 252 million years ago, Earth experienced the most severe biological catastrophe in its entire history. Long before dinosaurs dominated the planet, long before mammals appeared, long before humans walked across continents, life faced a disaster so extreme that scientists still study it today, in an effort to understand how close Earth came to becoming a very different world. This event is known as the Permian Mass Extinction. Many researchers simply call it the Great Dying. The name is well-deserved. Around 90% of marine species disappeared. A large majority of land species vanished. Entire ecosystems collapsed. Food chains broke apart. For millions of years afterward, the planet struggled to recover. To understand what happened, we must first visit the Earth that existed before the catastrophe. At the time, the continents looked very different. Instead of the familiar arrangement visible today, most land was joined together in a giant supercontinent known as Pangaea. Imagine nearly every major continent connected into a single enormous landmass. The distances were vast. The interior regions were often dry and harsh. Seasonal temperatures could be extreme, yet life flourished. Forests stretched across large areas. Ancient reptiles wandered the landscape. Insects filled the air. The oceans contained reefs and ecosystems, unlike anything alive today. For millions of years, Earth appeared stable. Life evolved. Species adapted. The planet continued its slow geological journey. Then, beneath what is now Siberia, something extraordinary began happening. Deep underground, enormous quantities of magma started rising toward the surface. Volcanic activity increased. Cracks opened across the land. Lava emerged. At first, this may have seemed insignificant on a planetary scale. Earth has always possessed volcanoes. Volcanic eruptions are part of how the planet releases heat from its interior. But this event was different, very different. Scientists call the volcanic region responsible for much of the crisis the Siberian Traps. The name comes from a geological term describing step-like lava formations, yet the simple name hides the immense scale of what occurred. These eruptions were among the largest volcanic events known in Earth's history. The lava covered millions of square kilometers. If modern humans had witnessed such an event, it would have appeared almost unimaginable. Entire regions transformed into volcanic landscapes, and the eruptions did not end after a few days, or months, or even years. They continued for hundreds of thousands of years, possibly longer. The atmosphere gradually changed. Huge quantities of carbon dioxide entered the air. Temperatures began rising. At first, the changes may have seemed small, but climate systems are interconnected. One change often triggers another, and another, and another. The Earth was entering a chain reaction. Global warming intensified. Oceans absorbed increasing amounts of heat. Weather patterns shifted. Many species found themselves living in conditions unlike those they had evolved to survive. The situation worsened. As temperatures increased, ocean circulation changed. Deep waters lost oxygen. Entire regions of the oceans became hostile to complex life. Today, scientists call these areas dead zones. During the Permian crisis, dead zones expanded dramatically. Marine ecosystems suffered enormously. Creatures that had thrived for millions of years suddenly faced conditions they could not tolerate. Many disappeared. Coral-like reef builders declined. Ancient fish populations collapsed. Countless marine organisms vanished from the fossil record. The oceans themselves were changing. And unfortunately, they were not finished changing. Scientists believe that warming ocean may have triggered the release of methane from the sea. Methane is a powerful greenhouse gas. Its release would have accelerated warming even further. This is one reason the Permian extinction remains so fascinating. The disaster was not caused by a single event. Instead, multiple environmental crises reinforced one another. Volcanoes altered the atmosphere. Climate changed. Oceans lost oxygen. Ecosystems collapsed. Each problem intensified the next. Like falling dominoes, one consequence led to another. The result became the greatest extinction Earth has ever known. Yet the worst phase was still ahead, because life on land would soon face its own crisis. The Day Earth Almost Died Part 2. As the environmental crisis intensified. Life on land began experiencing the consequences. The planet was becoming hotter, not slightly hotter, not a few degrees warmer. In some regions, temperatures may have reached levels that pushed many organisms beyond their biological limits. Scientists studying ancient rocks and climate models estimate that average global temperatures rose dramatically during this period. The interior of Pangaea, already prone to harsh conditions, became increasingly difficult to survive in. Imagine a world where heat waves lasted not for days, but for generations. A world where ecosystems slowly lost their ability to support the life that depended upon them. Plants began struggling, and when plants struggle, entire food chains become unstable. Herbivores lose food, predators lose prey. The effects spread throughout ecosystems. The Permian world was experiencing a planetary-scale ecological collapse. The fossil record provides evidence of this transformation. Species that had survived for millions of years suddenly disappeared. Entire branches of life's family tree ended. Some groups vanished completely. Others survived only in small numbers. Many organisms found themselves facing conditions they had never encountered before. Evolution can adapt to change, but sometimes change happens too quickly. And when environmental pressures become severe enough, adaptation cannot keep pace. The oceans continued deteriorating as well. In many areas, oxygen levels dropped dramatically. Marine life depends on dissolved oxygen, just as land animals depend on atmospheric oxygen. Without it, survival becomes difficult. In some places, nearly impossible. Researchers believe that large portions of the oceans became stagnant. The normal circulation patterns that distribute oxygen and nutrients weakened. The seas that once supported thriving ecosystems became increasingly hostile. Then another problem emerged: hydrogen sulfide. Today, this gas is associated with the smell of rotten eggs. In large quantities, it is highly toxic. Some scientific evidence suggests that oxygen-poor conditions may have allowed certain microorganisms to flourish. These organisms produced hydrogen sulfide. As concentrations increased, the gas may have spread through parts of the ocean, possibly even into the atmosphere. If this occurred on a large scale, the consequences would have been devastating. Many marine species already struggling with warming temperatures and oxygen loss would have faced yet another deadly challenge. Life was being attacked from multiple directions at once: climate change, oxygen depletion, toxic gases, habitat loss, food chain collapse. The crisis deepened. One reason scientists remain fascinated by the Permian extinction is because it demonstrates how interconnected Earth systems truly are. The atmosphere affects the ocean. The oceans affect ecosystems. Ecosystems influence the atmosphere. Everything is connected. When one part changes dramatically, the effects ripple outward. The Great Dying became a lesson written across an entire planet, a lesson in environmental interconnectedness. Meanwhile, on land, forests suffered enormous losses. Many plant communities disappeared. The landscapes changed. Areas that had once supported rich ecosystems became barren. Recovery was impossible, while environmental conditions remained unstable. And instability continued. Volcanic eruptions released not only carbon dioxide, but also other gases capable of altering atmospheric chemistry. Acid rain may have occurred in some regions. Soils changed. Water systems changed. The challenges multiplied. If a traveler could have observed Earth during the worst stages of the extinction, the planet might have appeared strangely empty, not entirely lifeless, but diminished. The diversity that had taken hundreds of millions of years to develop was vanishing, slowly in geological terms, rapidly in evolutionary terms. Entire ecosystems unraveled. Many familiar ecological relationships disappeared forever. The fossil record reveals the scale of the disaster. Approximately 90% of marine species vanished. On land, losses were also catastrophic. Scientists estimate that around 70% of terrestrial vertebrate species disappeared. Numbers like these are difficult to comprehend. Imagine 10 species. Now imagine only one remains. That is the scale of destruction experienced in many marine ecosystems. And yet, remarkably, life did not disappear entirely. Some organisms survived. A few species possessed characteristics that allowed them to endure. Some tolerated higher temperatures. Others adapted to low oxygen conditions. Some survived simply because they occupied the right place at the right time. Their survival would become one of the most important events in Earth's history, because from those survivors, future ecosystems would eventually emerge. But recovery would not happen quickly. Nature required time, a great deal of time. The worst extinction in Earth's history had fundamentally transformed the planet, and in its aftermath, Earth entered one of the strangest periods it had ever experienced, a world where life remained, but where much of the old world had vanished. The age before the catastrophe was over. A new chapter was beginning, and the road to recovery would take millions of years. The Day Earth Almost Died Part 3. When the worst phase of the Permian Mass Extinction finally ended, Earth was still alive, but it was a very different world. The forests that had once covered vast regions were reduced. Many marine ecosystems had collapsed. Countless species had disappeared forever. The planet was entering a new era. One of the most remarkable aspects of life's history is not simply that extinctions occur. It is that recovery occurs afterward. Again and again, throughout billions of years, life has demonstrated an extraordinary ability to adapt. The recovery from the Great Dying, however, was not quick. In fact, it may have taken millions of years before ecosystems regained significant complexity. Imagine a city recovering after a disaster. Roads must be rebuilt. Businesses must reopen. Communities must reorganize. Now imagine that process occurring across an entire planet, and instead of years, the recovery requires millions of years. That was the challenge facing life after the Permian extinction. The surviving species inherited a world filled with ecological opportunities. Many environments that had once been occupied were now empty. Predators had disappeared. Competitors had vanished. Food chains required rebuilding. Evolution began experimenting. New species emerged. Some succeeded. Others failed. Nature started filling vacant ecological roles. The oceans slowly recovered. New communities developed. Ancient reef systems eventually returned, though often in different forms than before. Marine ecosystems became increasingly diverse once again. The process was gradual, but it was happening. Meanwhile, on land, survivors spread into environments left empty by extinction. Certain reptile groups proved especially adaptable. They diversified. They evolved. They occupied new habitats. At the time, nobody could have predicted what would eventually emerge from these lineages. One reason is that evolution does not plan ahead. There is no blueprint, no final destination, only adaptation to current conditions. Yet the conditions following the Great Dying created opportunities unlike any seen before. The old world was gone. The future belonged to survivors. Millions of years passed. The climate stabilized. Volcanic activity decreased. Environmental systems slowly recovered. Forests expanded once again. Rivers carved new landscapes. Life continued adapting. And among the many reptiles evolving during this period were the ancestors of a group that would eventually dominate Earth: the dinosaurs. Today, dinosaurs often receive most of the attention when people discuss prehistoric life. Movies, museums, books, documentaries, and popular culture have made them famous. Ironically, their rise was made possible in part because of a catastrophe that occurred millions of years before the first true dinosaur appeared. Without the Permian extinction, the history of life might have unfolded very differently. The ecosystems that dinosaurs eventually occupied had been reshaped by the Great Dying. In a sense, one extinction helped create opportunities for future evolutionary success. This pattern appears repeatedly throughout Earth's history. Extinctions are tragic from the perspective of the species involved, yet they also alter evolutionary pathways. New opportunities emerge. New forms of life evolve. The story continues. Scientists often describe Earth as a dynamic planet. The Permian extinction provides one of the clearest examples. Nothing remained unchanged. Atmospheres changed. Oceans changed. Continents changed, life changed. Even today, evidence of the event remains preserved within rocks around the world. Geologists study volcanic deposits, paleontologists examine fossils, chemists analyze ancient minerals. Each piece of evidence contributes to a clearer understanding of what happened 252 million years ago. Yet questions remain. Researchers continue debating details. Exactly how rapidly did temperatures rise? How much methane entered the atmosphere? How severe were oxygen shortages? Science continues investigating. And that is part of what makes this story fascinating. The Great Dying was not merely a disaster. It was also one of the greatest scientific mysteries ever studied. The event reminds us that Earth's history is far more dramatic than many people realize. The world we know today is only the latest chapter in a story billions of years old. Countless ecosystems have existed before ours. Countless species have appeared and vanished. Entire worlds have come and gone. If modern humans could somehow visit the Permian Earth before the extinction, they would encounter unfamiliar landscapes and strange creatures. If they visited afterward, the difference would be astonishing. The transformation would seem almost unbelievable, and yet it truly happened. The rocks remember. The fossils remember. The evidence remains. Perhaps the most remarkable lesson is that life survived at all. The greatest extinction in Earth's history eliminated most species on the planet, yet not all. A small fraction endured. Those survivors became the ancestors of future ecosystems. Eventually, they gave rise to new reptiles, new forests, new oceans filled with life, and much later, mammals, birds, whales, elephants, humans. Every living creature today is connected, however distantly, to the survivors of that ancient catastrophe. Their success became our opportunity. Their survival became our history. The Great Dying was not the end of life. It was the end of one world and the beginning of another, a reminder that Earth is constantly changing, a reminder that life is remarkably resilient, and a reminder that beneath our feet lies a history far stranger, older, and more dramatic than anything most people imagine. Long before cities, long before nations, long before dinosaurs, the planet faced its darkest biological crisis. And somehow, against extraordinary odds, life found a way to continue. The Earth almost died, but not quite. And because it survived, so did the future.